Next we want to see the addition rule of the probability. Okay, now what is addition rule of the probability? Addition rule of the probability is used to find out the probability that at least one of the event is going to occur. Okay, that means you have, let's say, two events, A and B. These are the two events. I want to know what is the probability that either A will happen or B will happen or both will happen. So it is like both, at least one. So this can happen or this can happen or both will happen, right? So how it is to be represented? So what we do is we use the Venn diagram to explain this. You would have seen in your school days also. Okay, you have, this is your event A, okay, and this is your event B. Okay, we want to know that what is the probability that A and B, A or B will happen. So A or B. So think about the probability of happening of A. Let me draw like this. Okay, or right, this is A, this is B. So this is your probability of A. Okay, then this is your probability of B. So if you write that probability of A or B, if you write like this, PA plus PB. So what is happening is this part, okay, you see that it is coming twice. So it means that I have to remove this part from the system, and this part is what? This part, if you see, that is both A and B are going to happen over here. So PA plus PB, okay, minus PA and B. Okay, now it depends on whether these are independent or dependent. You can accordingly choose. If they are independent, this will be the value. If they are conditional, A is conditional on B, this is the case. If B is conditional on A, this is the case, right? So but generic way we can say that PA plus PB minus PA and B. So this will be your addition rule of the probability. Now we bring another concept which is known as the total probability. Okay, total probability is also known as the unconditional probability. Okay, so we have brought this earlier, the concept of the unconditional probability we said as the marginal probability. Okay, but in case of conditional events or dependent events, we can also get the unconditional probability concept clear, right? So what they are saying is, this is your also known as unconditional probability. This is a probability of occurrence of the event when conditional probabilities are given. So when conditional probabilities are given, what is the probability of occurrence? So think about, we bring the same case as Dhoni playing, the probability of Dhoni playing in the team, okay, and then probability of Dhoni not playing in the team. Okay, now when Dhoni plays, India can win. Okay, so we say that probability India winning given Dhoni playing. So what I am doing is I am creating a tree diagram to explain this concept. So this is one path, this is one node, this is one path, this is one node. Okay, right? So we are saying that this path, the probability is India winning given Dhoni playing. This path, probability of Dhoni playing. Then we have this path. Okay, we can say here there are two ways possible. See, here you have two ways possible, that Dhoni can play or Dhoni cannot play. Here similarly you have two ways possible, India can win or India may not win. So we can say that India not winning given Dhoni playing. This, when I have A and I write A bar or A dash or A complement, each of these means that A is not happening. Here it means A is happening, and this means that A is not happening, right? Similarly, Dhoni may not play, but it does not mean that if Dhoni is not playing, India will not win. So India can win even when Dhoni is playing. India can Dhoni is not playing. India can lose when Dhoni is not playing. Okay, so you have actually these four nodes, 1, 2, 3, 4. Now if you see this node 1, what you have is, if you see probability of Dhoni playing and probability of India winning. So if I write this probability of Dhoni into probability of India winning given Dhoni, so this can be represented as nothing but we have seen earlier. This is what is the probability of Dhoni playing and India winning. If you see this node, what is the probability? If I multiply probability of D bar into probability of India winning given D bar, so this is nothing but probability of Dhoni not playing and India winning. Okay, so if you see this node, 1 and node 3, in both this node, okay, what we find that India is winning, but in this node Dhoni is playing, but in this node Dhoni is not playing. So what we get is, if I add the probability of node 1 and node 3, what I get is probability of Dhoni playing into probability of India winning given Dhoni, plus probability of Dhoni not playing into probability of India winning given Dhoni not playing. If I add these two, what I will get is, I will get the unconditional probability of India winning. It does not matter whether Dhoni plays or not. Once you have taken these two, the addition, okay, addition of this and this is a conditional, this is a joint probability with a conditional that Dhoni is playing. This is another joint probability with conditional that Dhoni is not playing. If you add these two, what you get is, you get the probability of India winning, which is unconditional probability of India winning the match. It is not dependent on whether Dhoni plays or not. Okay. So this is what we have. You can say that PA1, A is dependent on, like, there are various scenarios that are there, A1, A2, AN. So A1 is where we are saying that probability of A given B1 into probability of B1. Okay, you have A2 is probability of A given B2 into probability of B2, like that. So what we can do is, we can write the probability of A, we can do all of this, we can do the addition, and we can get the probability of A. So this is your total probability, and also it is called as unconditional probability. Why it is total probability? Because you are covering all the situation. This can also be seen from the diagram. So you have probability of B, probability of B bar, and you have A given B, and the similar way that we have structured the node.